the next part, that is multiple granularity. So multiple granularity means what? See, in some cases there are some circumstances where we need to or advantages to group the several data items and to treat them as a single unit. To treat them as a single unit. For example, suppose a transaction TI want to log the entire database. A transaction TI want to use the entire database, want to read the entire database. So in that case, how it is possible to log the entire database? In the database, suppose there are thousands of data items. In the database, suppose there are thousands of database, then it needs to use 1000 or request 1000 different logs on the data items. And it is very time consuming. It is very time consuming and also costly. Is it clear to everyone? See, once again I am repeating. There are some circumstances where it would be advantageous to group the data items together, several data items together, and to treat them as a individual synchronization unit. For example, suppose the particular transaction TI want to read the entire database. So how to read the entire database in our simple tree protocol? It needs, suppose there are thousands of database, then it requests 1000 log instructions on these 1000 data items. And it is very time consuming and costly. So what is the problem or how to solve this problem? So to solve for this, allow the data item to be of various sizes. Allow the data group together then as a various sizes. Okay, and define a hierarchy of data granularity. Define the hierarchy of data granularity where small granularities are nested within the larger one. Where the small granularities are nested with the larger one, and it is represented graphically as a tree, but it is not a tree protocol. Tree protocol is different and the multiple granularity is different. Okay. So when a transaction locks a node in the tree explicitly, it implicitly locks all the nodes descendant in the same mode. Means if the parent is locked in some mode, shared mode or exclusive mode, all these children, whatever, all its descendants are locked in the same mode. So see here example, then it will be clear to you. Okay. So what is here? Here, this is divided into multiple hierarchies. Small granularities are nested within the large. So start with the database. First, start with the database first. So if any transaction want to log the database, you can log the entire database directly, not necessary to log the data items. So this database, the next stage is, it is divided into areas A1, A2 to AN, whatever. Then every area has some files and these files has some records. These files has some records. For example, in our case, we say it is a college database. Entire college database. We divide it into areas. For example, computer science, electronics, mechanical, civil, etc., etc., electrical, we divide it into areas. Then these areas has some number of files, means second year, SYCSE, TYCSE and BTech. Okay. Files. And these files has some records, means roll number 1 to roll number 68. Roll number 1 to roll number 70, whatever. Have you got the idea of multiple granularity? So whenever a transaction want to access the particular entire database, you can directly log the entire database, not necessary to log the records one by one. Thousands of, in our college, if we consider the student record, there are nearby 5,000 students are studying there. So instead of 5,000 locking 5,000 different records, the transaction can directly log the database, college database. Or if A transaction want only computer science related record. He can directly log the CSE, that area. If anyone want only ETC, can log only ETC. If anyone want only SYCSE record, then log this file directly. Automatically all these records are also locked in that particular mode. Is it clear to everyone? What is actual multiple granularity means? The entire database, it is divided or hierarchy in different hierarchy. Start with the entire database, divided into different areas. Each area has some number of files and these files have records. In our case, if we consider a college database, there are different areas, CSE, ETC, electrical, etc. Every area has some files, SYCSE, TYCSE, BTech, and in this way, every file has some records. So, if a transaction want to read the entire database, the transaction can directly lock this database in shared mode or read the database shared mode. So, automatically, all the remaining part, its descendants are locked in shared mode. If a transaction lock this file in exclusive mode, automatically all the records which comes under this file are locked in exclusive mode. Lock, that is shared lock and exclusive lock. Shared lock, it is used then only the data item we can read, and when the exclusive lock is used, we can both read and write the data item. So that is allowed for the transaction to both read and write that particular data item, Q or whatever the name of the data item. So in addition to S and X lock modes, there are three additional locks provided by this multiple granularity. Which are these additional locks? Intention shared. So intention lock mode is used in multiple granularity. So intention shared means indicates that explicit locking at lower level of the tree, but only in the shared mode. Means if the parent of the tree is locked in intention shared IS, then the all children of that particular parent is locked only with the shared lock. So already in the lecture also I told that in this, if the tree is explicitly locked, it implicitly lock all the descendants in the same mode. So if the parent is in IS, then all the whatever the descendants are locked in shared mode. Next, intensive exclusive indicates explicit locking at lower level of with exclusive and shared. Means if parent locked in IX mode, then the descendants are locked in exclusive or shared mode. And the last one is shared and intention SIX. This subtree rooted by the node is locked in SIX explicitly in shared mode, and the locking is being done at lower level with exclusive mode. So that we get to see it with example. Only remember these names and the definition. Intention shared IS, intention exclusive IX, and SIX shared and intention exclusive. So in locks that allow that higher level. Okay. Now see here. This is the compatibility matrix for these locks with lock modes with intention. IS is compatible with IS. IS is compatible with IX. IS is compatible with S. IS is compatible with SIX, but IS is not compatible with X. So this entire compatibility matrix is used while granting the locks. Means if a particular file is locked in IS mode by a transaction and another transaction wants the same file in IX mode, then that is allowed. Why? Because both are compatible. Have you understood? I'm going to show it with. Okay. Here, if a particular node or the file or area, whatever, is locked by a transaction, by any transaction Ti. Suppose transaction T1 has IS lock on the data item Q or the area A1 on the area A1, and another transaction T2 wants the same IS lock on the particular area A1, then it is allowed. Why? Because these are compatible. Suppose another example, in transaction T1 locked the file FA in IX mode. The transaction is requesting the same file FA in S mode, then it will be not granted. Why? Because IS and IX are not compatible with each other. So using this compatibility matrix, the transaction allowed to lock the particular data item. So multiple guarantee rules there, as we have seen already, for lock based protocol and for graph protocol. In the same way, okay, so I can lock a node using the following rules. What are the rules? The lock compatibility matrix must be observed. That already I have told you, that every time when a transaction requires a lock to the control scheme, the concurrency control manager check whether that data item or that particular file is locked by another transaction in compatible or non-compatible mode. If it is in compatible mode, then the lock is granted. If it is incompatible mode, then the transaction need to wait until another whatever the previous transaction release the lock. So every time before granting the lock, the concurrency control manager check the compatibility matrix. Then the root of the tree must be locked first and may be locked in any node. So in this, the second and the important is that root of the tree is locked first. Means what is the root here? Entire database and then area. Okay, entire database and then area. So what is the rule? Second rule, the root of the tree must be locked first and may be locked in any node, whatever the requirement of the transaction. If the transaction only want to read the data item, accordingly the database is locked. If the transaction want to perform some updation in the descendants, then accordingly the database is locked in exclusive mode. So according to the requirement of the transaction, first the root of the tree must be locked and then the descendants. Okay. A node Q can be locked by Ti in S or IS mode only if the parent of Q is currently locked by Ti in either IX or IS mode. Means suppose parent, we consider the file and the records in that. So file of ICSE, the records are there, RA1, RA2 up to RA. Total you have 100 and something students, suppose 110 students, considering both the division. So in that case, what here the rule is that a node Q can be locked by Ti. Suppose a transaction Ti want to lock this node, any one of these or this entire records in S or IS mode. S or IS mode, shared or intensive shared, then if and only if the parent, what is the parent? FA is the parent. So first we need to lock the parent in IX or IS mode. We need to lock the parent in IX or IS mode. Means what? The parent is locked in higher level than descendants or than the children or child. The parent is locked in higher level than the child. Now see here the next rule. A node Q can be a node You can be locked by IX IX mode only if the parent Q is locked by TI in IX SIX mode. Okay. A node Q, suppose we want to lock this node or the transaction TI to lock this node in X, SIX or IX mode, then the parent must be first locked by IX or SIX mode. Again, the same rule, parent is locked in higher level or higher level mode than the children. So if we want to lock this, first we need to lock the parent. Accordingly, we need to lock area. Accordingly, we need to lock the database. So first, the root of the tree is this database is locked first. Only it has not previously unlocked any node. Means it is two phase. See, TI can lock a node only if it has previously unlocked. TI unlock a particular node, then not allowed to relock any other node. Means once it is entered in the shrinking phase, not allowed to lock a new data item or new area or new file, whatever. So that is another rule, that it should be a two-phase. Means all the locks are acquired. The transaction enters into the shrinking phase, any one of the node, the transaction not allowed to lock any other node after it. So it is. Then TI can unlock a node Q only if one of the children of Q are currently locked by TI. Means what? Suppose transaction TI has locked the file and this transaction locked this in IX mode and all these in X mode. So TI can unlock node only if none of the children is locked by TI. What we need to do first? We need to first unlock. We need to first unlock the of this particular node. First, we need to unlock the children, and when we can unlock the parent. First, children are unlocked and then parent. So, what we observe here that the locks are acquired from root to leaf. Locks are acquired from root. Database is locked area, then file, and then record. But unlocking is done in opposite way. It is from leaf to root. It is from leaf to root. Unlocking is done in opposite way. First, all the children or descendants are locked, and then the parent is unlocked. So here we observe that locks are acquired in top-down manner in this way, while unlocking is done in bottom-up manner. Now see some examples of it with the same thing, that multiple methods of database area for record. Suppose that the first example, suppose that transaction T21 reads the records of RA2. Suppose the transaction T21 want to read the records of RA2. RA2 means these records. In file FA, in this file, the transaction T21 want to read the record. So read means only shared mode is present. The transaction want to read that record. So in that case, what we need to lock first? We need to the database, area, and file. Here it requires shared mode. Correct? Only want to read. But the parents are locked in higher level. So minimum IS is here. So that is the first example. Means in that case, we need to lock the database, this area, and the file in this order. First, database is locked in IS mode, then area A1 is locked, then file FA is locked, and then at the end, record RA2 is locked in shared mode. So This is third T21. Suppose the transaction T22 modifies the record RA9. Want to modify the record, want to write the record. So in that case, RA9 means again it is from this file. Suppose it is RA9. This record want to modify means it requires which mode here? Mode. Am I audible to everyone? Because I don't see here the screen sharing option and that. Am I audible to everyone? Screen is visible? Okay. Screen is visible? Now see, 22 want to modify the record RA9. Want to modify the record means when we want to modify the record, the transaction want to modify the record, it requires the exclusive mode. It requires the exclusive mode. So before that, the area database, this area and this file must be locked in IX mode. Must be locked in IX mode, and then this RA9 is locked in exclusive mode. Suppose that section T23 reads the records of this file. Okay. Suppose the transaction. 1 minute. Suppose the transaction T23 reads records of file F1. Want to read the record of this file. Means all the records want to read. So in that case, reading means only shared mode is sufficient for here, but before that, the database and this area is locked in IS mode, and then the file FA locked in shared mode. So automatically all the records are locked in shared mode as it is descended. Suppose the transaction T24 want to read the entire database. Want to read the entire database, then transaction T20 database in shared mode. Directly log this database in shared mode and read the entire data. So if multiple granularity we are not using, if we are using the simple method of lock-based protocol, then in that case, if you want to read the entire database, and if there are 5,000 records in the college database, then 5,000 locks are required in that case for that transaction. The transaction first requests RA1, then requests RA2, then RA1, RA10, all the 5,000 records. One by one, the transaction request is to concurrency control manager. Once the lock is granted, then only the transaction read that 5,000 records one by one. But the multiple granularity, it is possible that the transaction the entire database in shared mode and log the entire, not necessary to log it one by one and read the entire records in the